Good evening.
Good evening.
Good evening.
Good evening.
Welcome to this last session for today. Okay. It's a real pleasure for me to chair this session. So we are running a little bit late. So if you don't mind, I would go straight to the first speaker. So the first presentation is by Angioletti, Cassioli, and Balconi, and the title is Ambient Intelligence Between Good and Evil, Possible Neuroethical Implications for Individuals and Society. So please, you can start. Fantastic. Thank you very much.
Yeah, thank you. Can you see my slides, my presentation?
Perfect. Yes.
Okay, so thank you, Professor, for the introduction. I'm Laura Angioletti. I'm a PhD student at the Catholic University of Sacred Earth of Milan. And today I will speak about ambient intelligence. Right now, ambient intelligence is a discipline that makes our everyday environments sensitive to us. Try to think about train stations, for example, that now has, for example, ADV panels changing the advertising according to our preferences or tastes, and those information are taken from, for example, our smartphones. But now HAMI is totally around us. For example, we can find it at the workplace, in public spaces, in schools, in hospitals, and also, for example, in a smart city, but more interestingly, in our living rooms in our house. The concept of ambient intelligence is based on a paradigm and on a basic idea. The Internet of Things is a paradigm according to which everyday objects have the ability to identify, to detect, and to connect and process the information. While the basic idea of ubiquitous computing is that all the devices that are collecting the information should be integrated in the environment. In this case, in this presentation, we will mainly focus on domotics. Domotics is also known as home automation, and also in this case, this discipline is a discipline that is interdisciplinary and connects knowledge from informatics, engineering, but most interestingly also from psychology or, for example, from user experience insights. And in general, it delivers way to improve the quality of life of the people that live inside the habitation. Usually these environments are associated to adjectives like smart or intelligence because they have a certain degree of automation, and they can, in a flexible way and in a multifunctional way, to answer to our needs and to provide optimal solution, but also safety solution to our everyday lives. They also have the possibility to activate different interactive scenarios. And this is a part of the parse constructs of this presentation. If we take a step back, so far, no neuroscientific research investigating the experience of users inside smart home systems. Recent reports reported that evaluative studies mainly investigated this experience, while we think that a neuroscientific methodology will be able to detect indices that comes directly from our peripheral, but also from our central nervous systems, giving us the possibility to understand the intention, the perceptions, the emotion, and also the activation levels that the human being experience during the human-machine interactions. And this can be useful for designing the environment, to implement the user experience, or also to better adapt these environments. Also, for example, in case of clinical needs, for example. In this case, what we have done in this study is just a little part of a bigger project. We aim to investigate the difference in the eye behavior, so behavioral indices related to the activation of different sensory scenarios belonging to the field of home automation, so to a specific domotic show loft. And also we try to understand how this behavior varies according to individual differences. So we collected a sample of 20 subjects with an average age of 25 years old, and on the left, and we asked them to interact with this domotic show loft through an application that is this one, Domino. During the exploration, the participants were asked to interact with different tech areas inside the domotic show loft. And in these scenarios, they were asked to activate some commands that has a certain degree of complexity. So, for example, they were asked to interact with lights and to access the kitchen, also to a specific living room, to the bathroom that provided multisensory experience, while the bedroom has a particularly safety commands. During this exploration, we consider different behavioral metrics, such as the number of fixations, the time to first fixation, and the fixation duration. And at the end of the experiment, we asked the participant to fill in 2 questionnaires: the locus of control behavioral scale and the behavioral inhibition and behavioral activation scales, to investigate individual differences in reward and motivational tendency. We run some ANOVA models on this data, in particular on eye tracking data, and our first results show a higher number of fixation, in particular in the entrance condition compared to the living room condition. And this data was interpreted as a function of visual exploration behavior and as a sign of easiness to process and to pay attention to less elaborate and simpler tech interaction areas. And in this case, this was the hall. At the entrance. The second data instead regarded the second significant result concerned the time to first fixation. And in this case, we found that a more complex interaction, that in this case was the bathroom, required more time to be fixated for the first time compared to the kitchen and to the living room. And this, in this case, this data could be a possible interpretation is that this behavior could be an indication of motivational tendency and attention specifically to this tech area. As I said before, we also performed a correlation between psychometric data and eye tracking. And regarding the individual differences in 2 conditions, in the living room and in the bathroom interaction, we found 2 negative correlation between the external locus of control behavioral question scale and the number of fixations. I mean, for the tracking metrics. And these results could be interpreted as a tendency for people that has a low internal locus of control. So people that attribute small importance to unpredictable factors, or people that are less convinced that their action are a result of external factors, to explore more actively these tech interactions and showing more interest in them. As a second result regarding the BIS-BUS scale instead, so concerning the motivational tendencies, we found a correlation between a subscale of BIS-BUS, that is the BUS reward responsiveness scale, and fixation duration, both for the bathroom and for the living room conditions. And in this case, a possible interpretation is that data might indicate a tendency for people that has higher level of bus reward responsiveness scores to explore more these points of interaction with a reduced time in fixation duration average, and so a tendency to explore more these specific areas. In general, the idea of these studies is that we can collect brain and behavioral data to better design these environments, and those research can contribute to understand individual differences, but also user responsiveness to these smart environments. While conducting these studies, this research also raises concern on the quantity and on the use of the information that is possible to collect when we interact with these environments, but also from these environments. And indeed, an extensive set of data can be collected by smart devices from, of course, self-report and individual differences information from neuro or psychophysiological correlates. So neuroscience can be interesting and useful to explore this experience, but also it raises some issues related to privacy and cognitive liberty, and this was also solicited by other authors. To conclude, we highlighted that these studies can provide a new look and perspective on smart of systems and HAMI. This study was not aimed to optimize the system, but only to understand the user cognitive attention toward some interaction areas within this environment, these specific environments. That was highly ecological, and in the case of neurophysiological data, we can collect them without an explicit cognitive bias. There are also some weaknesses, but to go quickly to the traits and to, we can say, the evil part and the perseverance of this presentation and of this field of application, regarding the possible traits, we must be careful about, for example, these 5 issues that are the effect of surveillance, because if these technologies can also provide some advantages to the user. Also, the downside is that they provide a sense of constant monitor of our action, but also our thoughts and our behavior. And the person can feel a sense of judgment, and in a sense can also change his action and his behavior according, for example, to set standards. The collection also of data led to other big challenges connected to privacy protection. So, for example, if we think about people that during this period and during this pandemic are working from home, from domotic houses, from smart homes, for example, they can be monitored, for example, also at home. So they can be controlled in whatever they do and wherever they are. And again, as I just mentioned before, these environments can provide an extensive profiling, and this profiling can reach even, for example, biological and peripheral or neurophysiological data. Indeed, so far, for example, there are new developments of mirrors in the bathroom, in the domotic houses, that can collect information about the color of the skin and give to the person advice about related to the need for asking a clinical consultation, for example, for medical purposes, for medical reasons. And but we also know that this extensive profiling is in a sense needed for producer of domotic show loft to deliver the benefits that are provided from these these environments. The collection of this data, in another sense, have also an importance related to knowledge, because the person that the designer and the producer that are designing and building these environments can control the data that are collected and have the power to look at them, and also to have a specific knowledge on them, and eventually to share them with other people. And so there is also the issue, but this is interesting for more the legal compart about the data protection, how to protect this data, and in particular data related to the neurophysiological and body system. So to conclude, the new opportunities regard, for example, the possibility to develop a new approach that is more based on control and responsibility rather than on restriction and prohibition, and also to implement the transparency of the processing of the data that are generated and relating to these systems, in order to improve the control that the users have on their data. Thank you for your attention, and I'm here for any question.
Thank you, Laura, for your presentation. It was very, very clear. So we've got questions for Laura. Any question? Then I'll ask you one. I see that the age, the mean age is 25. So do you think that this would, would you expect differences depending on whether, on age? So for instance, older people, not just because they're less familiar with this, with this system, but simply because they know what to expect from a bathroom, for instance. So you might find that a different result with respect to the locus of control. So it's not, I'm serious. So what do you expect differences?
Yeah, thank you. Thanks a lot for your question. Of course, that's totally serious, because there are studies comparing the differences related to age. And in this case, there is also the digital divide that is focusing on the differences related to age in this field. So I don't know what we could expect related to locus of control, but this is really interesting. And of course, there could be possible differences, because those participants were mostly millennials, and the sample, as you saw, was reduced. So it will be interesting also to increase it and compare to different ages, but also differences, for example, also in gender. We didn't find any difference in this case, but it could be interesting.
Thank you. Maybe next project.
Thanks.
Okay, so there's a question by Andrea Lavazzo.
Thank you for your presentation. I agree with you on the fact that these projects can pose some threats on privacy and so on. I think that domotic houses in general can enhance the feeling of control in people, in that they think they can have better safety systems and so on. And they do not realize that their data are collected and possibly shared. So I'm wondering if a way to make people more aware of this is to introduce some unusual and disturbing, so to speak, features of these devices, in order to make people immediately aware when they, for example, switch on a specific device. What do you think about that?
Yeah, that's thank you, Professor. That's a good insight and idea, and I think we could think about to two experimental manipulations, for example, one in which the system correctly answers to your command, and another one in which it doesn't answer to the command, to see how the person will answer, will reply to this, will react, maybe also neurophysiologically speaking, to this interaction. So it will be really interesting to check this, but I don't know if there is something like this in the literature, but of course it will be interesting. And I agree in a sense, because also we saw that the person were quickly looking at the environments right after having activated the command from the smartphone, the interface. So they were right there to check the effect of the action. So that's a good point.
Thank you.
Thank you too.
Thank you very much, Laura. If you don't mind, we move to the next presentation, which I believe is from the same group. So the first speaker is Fronda and Balconi, and the title is How Ethics and Moral Cognition Influence Decision-Making in Professional Fields, the Contribution of Neuroscience. I'll give the floor to Fronda, please.
Good evening, can you see my slide? Now can you see my slide?
So now yes.
Okay, thank you.
Go ahead.
Thanks for the presentation. I'm Giulia Fronda. I'm a researcher of the Catholic University of the Sacred Heart of Milan. And this research wants to investigate how ethics and moral cognition influence decision-making in a professional context with the contribution of neuroscience. The focus is on decision-making that is configured as a complex process that involves different decisional systems as deliberative or intuitive ones. Deliberative systems are more supported by consciousness and rational processes. Instead, intuitive systems are more supported by emotional and affective responses. In particular, moral decision-making and decision-making with moral implications represents a complex process that requires individuals to make decisions that can harm or help others, demanding a balanced achievement between personal and other interests and the evaluation of personal and social rewards and emotional and rational processes. So moral decision-making has important implication in different daily situations of individuals as the company and the workplace context. Specifically in the company context, moral decision-making is fundamental because it can produce positive or negative social consequences that influence the organizational well-being. For this reason, in this research, we want to investigate the neurophysiological correlates and conscious and unconscious neurophysiological correlates underlying moral decision-making in a company context. In light of this evidence, this research wants to investigate, firstly, the implicit and explicit and conscious and unconscious neurophysiological correlates underlying moral decision-making in a company context, and also the involvement of cognitive and emotional processes that influence moral decision-making in a professional field. Moreover, this research wants to investigate the influence of some factors such as morality, fairness and unfairness perception, and social and personal implication that can influence decision-making in a professional field. And finally, this research wants to investigate the neurophysiological correlates, and in particular electrophysiological, hemodynamic, and peripheral and behavioral correlates underline moral behavior in a company context through the use of a specific task. In particular, this research was conducted on a sample of 18 participants, managed from an Italian company. And to investigate moral decision-making, we have used a specific task consisting of a modified version of the ultimatum game. In particular, the ultimatum game is a behavioral economic game in which two players can divide a sum of money. And this game involves two participants. One player is defined as the proposer, who makes the offer on how the sum of money could be divided, and the other is the responder, who can accept or reject this offer. In particular, in this modified version, created ad hoc for this study, we have three different conditions of choice. The first one, called professional, in which participants have to decide about the division of an extra paid job with a colleague, done with a colleague. The second condition of choice required participants to decide how much money investigate for the insert of some benefits in their company context. And the last condition of choice required participants to decide how much money donate for the cure of a sick relative of a colleague. For each condition of choice, three different offers were proposed to participants: a neutral offer that proposed an equal division of the money between proposer and responder, a fair offer that proposed an advantageous division of the money for the responder, and an unfair offer that proposed an advantageous division of the sum of money for the responder. During the execution of the task, cortical, hemodynamic activity, and peripheral activity were recorded with the use of functional near-infrared spectroscopy to the recording of the variation in oxygenate and oxygenate hemoglobin levels, cortical activity through the use of an EEG system with 16 channels, and the peripheral activity with the use of biofeedback for the recording of the variation concerning electrodermal and cardiovascular activity that provides information on physiological arousal of individuals. From the results of this study, we can see a different modulation of peripheral and central responses of individuals according to the three different contexts of choice and the three different types of offers proposed. In particular, starting from peripheral measures, we can see an increase of emotional engagement of participants and emotional arousal, with an increase of heart rate activity and skin conductance response during professional fit condition and during the presentation of fair and neutral offers in professional and social fit condition. And these results can be related to the fact that professional fit condition is more involving for individuals implicating their personal interest, while social fit condition is more involving for individuals implicating social interest. On the contrary, we can see, according to company fit condition, an increase of cognitive and attentional processes of individuals for this type of condition. We can see a similar trend regarding hemodynamic activity recorded with the use of functional near-infrared spectroscopy, with an increase of positive emotional response of individuals, with an increase of the level of oxygenate hemoglobin in the left side of the dorsolateral prefrontal cortex during the presentation of professional fit condition. And we have interpreted this result according to the dual system model of the neural signatures of affective experience that postulates a direct association between hemispheric asymmetry and perceived emotional balance. And also we can see from the results of hemodynamic activity a more involvement of cerebral areas for professional fit and social fit condition that are most involved in emotional, moral processes and prosocial behavior, with an increase of oxygenate hemoglobin in dorsolateral prefrontal cortex and superior temporal sulcus. Regarding EEG results, we can see a similar trend with an increase of attentional processes during company fit condition, with an increase of alpha power in frontal region. And regarding professional and social fit condition, we can see an increase of beta activity in the left frontal region associated to an increase of individuals' positive attentional responses, and an increase of delta and theta bands activity in the left frontal and parietal regions according to professional fit condition and social fit condition. And we can see an increase of the activity of these frequency bands in frontal region when are implicated emotional and social processes. Finally, regarding behavioral results, we can see that during the presentation of professional and social fit condition, there were an increase of accepted responses of individuals during the presentation of fair and neutral offers in these conditions. Instead, on the contrary, in the company fit condition, we can see an increase of reaction time during the presentation of unfair offers. This result can be related to the use of a more significant cognitive load for choices with a higher uncertainty degree for individuals. From these results, we can see differences responses regarding neural, peripheral, and behavioral responses of individual concerning the presentation of different choices, different contexts of choices, and different types of offers. Specifically, we can see that during the presentation of fair offers in professional and social fit condition, we can see an increase of emotional responses of individual, probably due to rewards in personal and social terms for individuals. Also, from these results, we can see that moral decision making seems to be influenced not only by individual factors, but also by contextual factors and contextual evaluation of individuals. And also we can see that moral decision making in a company context can be influenced by an individual and personal interest of individuals and social interest, and evaluation that influence moral decision making represents a continuum between individual personal interest of individuals and social interest. And finally, this study shows that the use of a multi-integrated neuroscientific paradigm call to investigate the neurophysiological correlates underlying moral decision-making in a company context, with the aim of improving decision-making for the design of new lines of intervention useful for the improvement of relationship and collective performance. Finally, for future implementation of this study, we can investigate moral decision making in other specific professional fields or in target groups from different population, and also we can see different types, for example, of neuroimaging tools for the investigation of brain structures in depth. Thanks for the attention.
Thank you very much, Giulia, for your interesting presentation, very clear. Are there questions for Giulia? If not, can I ask you one?
Yes.
So your group was constituted of 18 managers, right?
Yes. Yes.
So were they all males?
We have the same numbers of males and females in the sample.
Yeah. To which, I mean, would you expect any difference in the data you found, in the patterns you found in a population of people working in the public administration or at university? So it's difficult to say whether there is something specific to these guys. I expect, but I mean, do you have any comparison with the non-manager people, or even managers working in different types of companies? You know, like some aggressive company betting monies, or another or other kind of companies doing, I don't know, like services, for instance.
Thank you for the question. In this first pilot study, we have considered this target of managers, but in future implementation of the studies, we will consider a comparison group, a control group of non-manager, and also we will consider different types of professionists. For example, manager less competitive, or other types of professionists with different skills, with different mentions, for investigate the differences in the moral decision making, in the evaluation, and in the consideration of personal and social differences that can be different in different types of targets of population.
No, I mean, I understand the point of expecting some particular patterns in these guys, but unless you compare them with people working in another environment, it's very difficult to say whether there's something specific to them, you know. And so this is one thing. And the other thing, maybe you might need other scales, other information. You might want to collect different kind of information about these participants. So on other scales concerning empathy or other things.
Yes, it's right. And for this reason, in future implementation, we can consider also the collection of self-report measure and behavioral measure regarding, for example, empathy or other measure specific for the different works of individuals. Thank you.
Thank you very much, Giulia. So, well, now I have the honor to introduce the last speaker of this session. Thank you very much, Giulia. I think we switch to Carmelo Vicario now, which is going to present a paper together with other authors, Rafal, Pellegrino, Lucifora, and others. And the title, you can read it there: Indignation for Moral Violations Suppresses the Tongue-Motor Cortex. Take it away.
Thank you very much, Raffaella. The honor is all mine, you know. I don't know if you can see my presentation. Can you confirm me this? Okay. So I suppose you must be super tired, so I'm not going to stress you more. Just very few slides for you tonight, this evening, sorry. I'm just going to introduce and address a very simple question, which refers to a possible origin of morality related with the experience of disgust. So we have one, I want to do full screen. We have this paper, which is very inspiring for the study that I'm going to introduce you, that was published on Science more than 10 years ago. First name Chapman. These guys performed a very elegant experiment. They measured the image activation from this specific muscle that you can see here, which is the levator labii superioris, which is special for the experience of disgust, because it's the muscle that typically is more active when people perceive disgust. So is disgust, so is the oral nasal rejection muscle. So they confirmed previous evidence about its higher activation while while participants were experiencing unpleasant liquids. You see the activation is higher. And also higher is when people were looking at pictures of disgusting outcomes like contaminants, for example. The other conditions are control conditions. But the very interesting part of this story refers to the last experiment that they did, which is measuring the levator labii activation while dealing with the ultimatum game session. So they found that in response to unfair monetary offers, the activation of this muscle is higher, as well as in the experience of unpleasant taste and while looking at contaminants. So they concluded, and this actually was published on Science, so that the original morality may be oral, in the sense that morality and disgust may be deeply linked. And this evidence is in support of the neo-sentimentalist perspective on the original morality, which states that morality may originate from emotions. And in particular, these authors talk about disgust, even if other emotions like anger can be involved in this process. So according to this evidence, we figured out a possible new experiment that could investigate at central level, so at cortical level, what is going on in the tongue model representation when people perceive sensory disgust or social disgust and even moral disgust. So the methodology is here. We recorded tongue motor evoked potentials. So this is a graphical representation of our measure. And for people that are not familiar with the methodology, I will prepare a very, very short video that I'm going to present to you now. So we are recording the tongue model evoked potentials. This video was recorded a couple of years ago in Dortmund in the Michael Nitsche lab. I was there for a while. So as you can see here, we have our measure. Okay, sorry, because okay. So what we study is this wave. So the amplitude, the peak-to-peak distance, how this is modulated by the experience of disgust, including moral disgust. So in a preliminary study, we recorded tongue motor evoked potentials from the tongue or from a control muscle while people were looking at disgusting food like moldy food, or faces expressing disgust or social disgust. And we found that in the disgust condition, even for social disgust, the amplitude of tongue motor evoked potential was reduced compared to neutral and the positive condition like fresh food or faces expressing happiness. And no effects was found in the control muscle. So this study shows that actually the tongue motor evoked potentials map the experience of disgust at sensory, visosensory, and the social level. But what about morality? So we performed, which is the core of this presentation, another study, a new study, where people were dealing with the moral dilemmas or control dilemmas as a control condition. So they were also invited to provide for each single dilemma that was presented during the experiment a moral disapproval rating, because we wanted to detect the subjective experience of a moral disapproval rating. And what we found, as you can see in this next slide, is that for high moral disapproval ratings, the amplitude of the tongue motor vocal potentials is reduced compared to the control muscle, but also compared to the condition where low moral disapproval ratings were provided for these moral dilemmas. And if we plot the subjective experience of moral disapproval with the corresponding map motor vocal potential amplitude for the tongue, as you can see here, we have a negative correlation. So the higher the moral indignation, the lower, the smaller the amplitude of tongue motor vocal potentials. A completely different trend was instead found for another muscle. So for the motor vocal potentials recorded from first dorsal interosseous, which was our control muscle. And this also makes sense according to the previous literature. So I'm going to finish just with 2 extra slides. The take-home message of this study is that the excitability of tongue motor neurons is inhibited by a moral indignation. This is what is suggested by the last study that I presented, as well as by the experience of visosensory and social disgust. And this suggests, if you want to do some kind of interpretation or speculation about this data, that moral disgust activates an avoidance defensive mechanism similar to that recruited for rejecting unpalatable food. So in conclusion, our results appear to support the original hypothesis of morality that was proposed by Chapman. And if you want to see a general theoretical framework where we can frame this discovery, we can also say that this discovery fits also with the neural reuse hypothesis, stating that neural circuit, which was in the origin created to serve a specific function, in this case sensory disgust, can be recycled to serve superior, more sophisticated functions like those related with the moral reasoning. Thank you very much for your attention.
Thank you, Carmelo. Thanks for being so fast in presenting your data and being clear in also providing the take-home message. Are there questions? So if I may, okay, then I'll leave Massimo to ask the question. Go ahead, Massimo.
Okay, thank you. Thank you for your presentation. Very interesting indeed. I was wondering whether perhaps I didn't catch I didn't grasp all the elements of the technical elements of the presentation, since I'm only a moral philosopher. But I was wondering, I knew the paper by Chapman in 2009. I was wondering whether this specific research adds anything to I mean to the causal interpretation, because you're talking about oral origin, the oral origin of the moral, so to say. And so the causal interpretation, meaning that not only that you have a co-occurrence of certain reactions of disgust and certain moral judgments, but the fact that you have a causal relationship between the first and the second. I mean, is there anything in what you have done that prevents any possible interpolation according to which there is some sort of judgment which may recruit different areas, perhaps more rational areas, so to say, at the intersection between the two things that you observed? I mean, is there anything that excludes this possible reading, according to which it is not a direct causation from the elicitation of an emotion and the generation of a moral judgment?
Yes, thank you. Very, very interesting question indeed. So in terms of causality, actually what this study, in my opinion, adds to the previous one, I'm talking about the one by Chapa and colleagues, is that we show a signal that comes from a cortical level, not from the face, which is the peripheral response. So it's something that is not necessarily related with an explicit communication or internal experience that happens at conscious level. Because we were not asking anything during the experimental session to participants in terms of expressing any opinion about what they were dealing with. Okay, so so actually the people were asked to stay relaxed all the time and just focus on the content of the dilemmas, but nothing more. In terms, sorry, I missed the other point. Is about the neurocorrelates, if I remember right.
Yes, if there is anything that can prevent any other things, perhaps higher level, computational level that is happening there that can mediate the.
So this this evidence suggests that disgust may affect morality, but more in general, I don't think that morality has only, let's say, an oral origin or an affective origin. We know from fMRI studies that there is a dissociation with an affective appraisal for moral outcomes and a cognitive appraisal about moral outcomes. And we know that at a neural level, there is a dissociation. The interesting part of this neural evidence, in my opinion, is that if you look at the neural activation related with the affective appraisal, the regions that are normally involved are the same regions that are involved in the experience of disgust. I'm talking about insula, for example, of intermediate prefrontal cortex. So this doesn't exclude that disgust and morality may be at some level linked, but this suggests that it depends on the appraisal of the participant. In fact, there is also another meta-analysis that provide a very weak support to this link between morality and disgust. My point is that it depends on which kind of appraisal you are going to consider when you speak about morality. So it doesn't exclude the role of disgust or morality, but I don't think that it's just a matter of disgust.
Thank you.
If it makes sense.
Carmelo, I'd like to make just one quick question and for a
Sure.
very short answer. So do you think this can be applied in some interventions, for instance, to, treat some some eating problems or things like that. So do you think you can condition by using this paradigm or not?
As always you are one step forward. You look at the future, and this is what we are now. I was not going to go.
I'm just older, Carmelo. Don't worry.
No, I was not going to speak about this, but since you are asking, we actually are working on this, not in clinical populations, but just to see if we can modulate appetite in healthy humans. And we also published something with transcranial direct kinase stimulation in single blind Bayesian control design. And this is the one research line that I'm going to address in my lab, and that may have some hope, may provide some hope at clinical level. Yes.
Yeah, I think it's an obvious application that you should be tried.
Yeah, we know that the tongue motor neurons are directly connected with the several regions of the reward system, at least in monkey. There is this study from Alipur colleagues showing that tongue motor neurons, only tongue motor neurons, not upper limbs or lower limbs motor neurons in the M1, are directly connected with the insula, OFC, and all this reward system network. So it makes sense to focus on this motor region, which may be special compared to the rest of the M1, I suppose. But only in non-human primates we have this evidence.
Sure. Well, good luck with the future work. So
thank you very much.
I'd like to thank the presenters for being clear, for presenting interesting data, and for rushing through this hour we had for us for this session. And I'd like to thank also all the participants, and enjoy the evening. Thank you very much, and see you tomorrow. Bye.
Raffaella, ciao.
Grazie.
Ciao,
Grazie a tutti.
Grazie.
Buonasera.
Buona serata.
Grazie.
Buonasera.